All right, in this example, we're going to come up with what our equation of a line is, but we're eventually going to erase this, and we're only going to be left with points, and we're going to have to figure out what the y-intercept is, as well as the slope, if we're only given points. But let's work up to that. So right here, let's just try to come up with what the equation of this line is right here. So we have y equals mx plus b form, or slope-intercept form, that we're trying to put it into. We need to figure out what the m is, or the slope. So since we're given a graph, we can count it out. So I'm going to go from one point to another, and it doesn't matter which points you use as long as the 2 points are on the line, and it doesn't matter which direction you go. So I'll go from here to here, for instance. So if I were to start here, this here is at 6, comma 4. That's what that point is. Okay, its x value is 6, its y value is 4. And here, this is the origin, so its y value is 0, x and y value are 0, comma 0. All right, so here, if I'm going to try to get from here back to here, I need to, the slope is the horizontal change, and instead of writing change, I'm going to write a triangle. Triangle means change in Greek, so in a Greek letter. This triangle is called delta. So delta is the Greek letter for what we call D, and mathematicians have chosen to use the Greek letter delta to mean change. So instead of writing change all the time, I can just say change through this triangle. And also, instead of saying change vertically, I could just say change in y, because that's what's happening, our change in y going from up to down or down to up. So instead of saying our change vertically up here, I'm just going to say delta y. And then I'll put over the change horizontally, which is left or right on the x-axis, and I'll do change in x. So this is a really quick way to write the slope formula. So change in y, delta y over delta x, right? So what is our delta y? If we're starting here and we want to get down here, we need a drop. All right, we need to drop 4. So we go drop 1, 2, 3, 4. So that was a drop in 4. Since we dropped 4, that is a negative 4, because it's a negative change. All right, we dropped 4, we're going down 4. Now that we're over here, we need to go to the left. How much do we go to the left to get back to the line? 6. Since going left horizontally is a negative movement, it's negative 6. So our slope is negative 4 over negative 6, which we can reduce to negative 2 over negative 3. Divide both by 2, negative 2 over negative 3. And then, since we have two negatives cancel out to just be a positive. So this whole thing, the slope, will not be negative 2 over negative 3, but just 2/3. So this is what the slope is. Now, we need to figure out what the b is. The b is always the y value of the y-intercept. This line crosses the y-axis at the origin, so our b is going to be 0, because here, b, so it's 0, comma b, is what our y-intercept is, because it's always going to be on the y-axis. So this value is always going to be 0. It's just the second value that we're looking for. Where on the y-axis are we going to be? And here we're at 0 as well. So this y value of the y-intercept is 0. So I'm going to put 0 right here. The b is 0 in this particular case because it goes to the origin. So this is the equation of this line. By the way, you don't have to write, if it's plus 0, you can drop the plus 0, because plus 0 doesn't add anything to it. So if you want, instead of writing plus 0, you're free to write y equals mx and then just drop the 0, if it's a proportional line, which it is here because it's straight and it goes through the origin. So long story short, we've got the equation of a line, and we have gotten it through counting out the slope and looking at the graph of what the y-intercept is. In the next video, we're going to come up with the slope and the y-intercept for the equation of the line, but not given any of these graphs. We're just going to be given points, and we're going to be asked to do that. So do you see that it needs to go up 2 for every 3 that it goes over? Think of this, let's go back to the example at the beginning of grape and blueberry juice, okay? And this line is the punch line, meaning that every point on this line makes a perfect mixture of punch, all right? So meaning right here, we need, this is ounces, okay? So ounces of grape and ounces of blueberry. Here, since this point is on the line, it tells us exactly how many ounces of grape juice and how many ounces of blueberry juice we need to make perfect punch. So here it says this is 3, 2, right? Which means that we need 3 ounces of grape and 2 ounces of blueberry juice to mix to make perfect punch proportionally. Here we need 6 ounces of grape juice and 4 ounces of blueberry juice to mix together to make perfect punch. If I had 6 ounces of grape juice but 7 ounces of blueberry juice, do you see that that point would be up here and that point would not be on the line? So it's a point, but it's not a point on the line, and therefore this point is not something that would make balanced punch. You see, it wouldn't make balanced punch because you would have too much blueberry juice in it. And so let's think of that for the next video. The points, the coordinates of the point need to make balanced punch or to balance the equation out. Meaning if I put 6, 4 into this equation, it would balance the equation out. If I put 3 in for x and 2 in for y, it would balance the equation out because it would make balanced punch.